I'm going to show you an easy way to do work energy principle questions that'll make you love them, hopefully. So, a suitcase of mass 23 kilograms is placed on a rough, sloped floor inclined at 60 degrees and is initially at rest. It starts sliding down, and after a distance of 30 meters, the floor becomes horizontal. It slides another 15 meters before finally stopping. The total resistance due to friction and air resistance is modeled as a force of constant magnitude of R newtons, which opposes the direction of motion of the suitcase. Find the value of R. So, in these questions, it always helps to draw a diagram with all the information you've been given. So first, we're told it's placed on a rough, sloped floor. So here is my rough, sloped floor, inclined at 60 degrees. The suitcase is going to be there. It's got a mass of 23 kilograms. So if I just write as weight, 23g, where g is 9.8. Okay, so that's initially at rest. So let's call this section A. Then it slides down 30 meters. So here, this section is going to be 30 meters down the slope. Then the floor becomes horizontal. So here is my horizontal floor. And it slides another 15 meters before finally stopping. So there is 15 meters. And this is my suitcase in its final position. The total resistance due to friction and air resistance is R newtons. So R newtons will be in this direction on the slope, because it's opposing the direction, and now it's going to be in this direction parallel to the floor down there. Okay, we've got all the information. Now let's go about solving this. The question doesn't tell you to use work energy principle. The reason you know to use it is because you can't resolve forces since it doesn't give you the acceleration. So you can't use F equals ma. That means consider the energies. So this is what I like to do. I've labeled this part A, and this is going to be part B. Now consider the energies in each section. So in A, is there kinetic energy? No, because it's at rest. Is there gravitational potential energy? Yes, because it's above ground level. And is there any work done due to resistive forces? Not yet, since it's at rest. Okay, part B. Is there kinetic energy now? No, because now it's stopped at B. Is there any GPE? No, because now it's on the floor. That's like our zero level. Now, is there work done against the resistive forces? Yes, that's what the GPE gets transferred to. So all we have to do is write this as our equation. So GPE, the equation for that is mgh. That is equal to the work done against the resistance, which is force times distance. Okay, now we just sub in some values. So what is the mass of this suitcase? 23 times g, which is 9.8, times by the vertical height. Here, they've given us 30 meters down the slope. All we've got to do is do a bit of trig to find what the vertical height here is. So this is 60, this is 30. So we can see we use sine of 60 is equal to the h times by 30. So that's 30 sine 60. And that is equal to the force. Well, they've told us the force value is R newtons, so we just call it R. And the distance is the total distance traveled. So initially, R is opposing the distance of 30 meters there. So you have 30, and then you've got a distance of 15 meters. And we're told that R is constant as a modeling assumption. So now, before putting this into my calculator, I'm going to rearrange, then put that in. So I know that R is equal to 23 times 9.8 times 30 sine 60, all over 30 plus 15, 45. If I put that into my calculator, I get 130.13 and so on, which means that R is equal to 130 newtons to two significant figures. So whenever doing these types of questions, consider A, consider B, do your energies, do your equations. And that's it.